Hey everybody, I'm going to do some solutions here for the 1.11 surface area problems. And let's start off here with number 9, part A and B, and then we'll do number 10. So this is on the last page of our packet. Find the value of x given the surface area and the figure. Okay, so first of all, I got x in the wrong place here. So let's fix this. We want to put x over here. Okay, so we have this prism and this length right here we can call L. This length right here we can call height, and this x right here would be the width. So there's a couple ways to solve this. We can make a net, which would be 6 rectangles all flattened out into a pattern. I'm just going to use the surface area equation though, which is the same as using the net. Ultimately, we've got 2 length times widths, so we have the area of this rectangle right here, which would be the length and the width, and we have the top one also, right? So that's why there's two of those, and we're going to add to that 2. Let's do the left and the right side. So that would be width times the height. So the width, let's do height times width. Height times width. And so we're talking about these rectangles on the left and the right side, right there. And we've got the top and the bottom. Nope, we already did the top and the bottom. We have the front and the back. So the front is the length and the height. Length times, let's do height times length. And so that's the front one here, and then the back one. Okay, so we know the surface area is 432 square meters. The length is 12. The width is x. So I recommend writing out this whole line here just with the equation, and then this line we are substituting. And whenever I substitute, I use parentheses. That helps me organize my work. Height is 6 and the width is x, plus 2 times height is 6 and the length is 12. Okay, so 12 times x, 6 times x, 6 times 12. There it is. Now we still have 432 on the left. And let's multiply. 2 times 12 is 24x, plus 2 times 6 is 12x, plus 2 times 6 is 12. 12 times 12 is 144. Okay, now we need to subtract 144 from both sides. And that's going to give us, what is that going to be? Let's see, we're going to borrow a 2 here. So that's 12 minus 4 is 8. And then we have a 2. We need to borrow a 1 here. That's 8. 3 minus 1 is 2. So we get 288. And then we have a like term here. 24x plus 12x is 36x. And then we're going to divide by 36. 288 divided by 36. Let's see. 8 times 3 is 24. Let's try 8. 8 times 6 is 48. 8 times 3 is 24, plus 4 is 28. There we go. 0. Okay, so 8. So x equals 8 meters. All right, that one's done. This is a cylinder. So the surface area equation for a cylinder is the two circle areas, so pi r squared, plus 2 pi r h. Now, why? I think this first part right here makes sense, but why the 2 pi r h? So if we make a net from this cylinder, we have our two circles here with radius r, and we have this is our height of our cylinder, and this curved edge right here just flattens out into a rectangle, right? But this edge here, see, let's find a maybe green. This wraps around this half of the cylinder, and then this side wraps around here. So this length here is the same as the circle's circumference, which is 2 pi r. And so this is 2 pi r. That's the length of our rectangle. So this part right here is the length of our rectangle. And the h, the height of a cylinder, is the width of our rectangle in the net. So length times width of the rectangle is the same as the circumference times the height of the cylinder. So that's where we get the equation. Okay, so we know h, we're calling x right here. That's the height, and the radius is 16, and the surface area is given. Don't forget about the pi. That's part of the surface area. So let's substitute everything here into the equation. 1,536 pi equals 2 pi 16 squared plus 2 pi 16, right? That's our radius here, times x. That's our height. Now, I see pi's in the equation here for each term. So we can divide by, actually, 1536 is also even. So why don't we just actually divide out 2 pi? Why not? So all of our pi's cancel, and all of our 2's cancel. 2 goes into 1,536. How many times? That's going to be, let's see, 2, that's going to be, I got to think about this. So 2 into, that's going to be 13, and 7 goes into 13 once. 2, 14, you bring down the 1, so we get 13. 7 goes into 13. Wait, what am I doing here? let's back up this train here. Back it up. We're having this, so that's 7, 14, bring down the 1. Okay, 2 goes into 13 6 times, and then you bring down that, and that's an 8. Of course, 768. 768 equals 16 squared plus 16x. Okay, did I do that right? Okay, and 16 squared is 256. So let's subtract 256 to both sides. And I get 16x equals 512. Is that right? So 2, 1, yep. I'm going to divide this by 16. And let's see, 512 divided by 16. And for brevity's sake, let's just use a calculator. That's right, it's 32. 32. 32 what? 32 inches. Okay. All right, so we saw it for a dimension for both of these. That's what we're doing for number 9. We know the surface area, and we don't know one of the dimensions. We just use the equation and solve. This last one, number 10, what is the surface area of the cement culvert? And I say cube dimensions here, but I'm actually not giving you a cube. Let's make this a cube by, let's make this 10 right here. For simplicity and elegance. Let's say the culvert is 10 by 10 by 10. So a culvert is a structure that holds up a road or a bridge, sometimes a bridge-like structure that allows the water to pass through. So it could be a stream or a creek of some sort, prevents the bank from eroding. So our dimensions, they're all over, by the way, culverts. They're rarely this dimension, though. 10, 10, 10, right? So we've got, basically, the sides are all the same, aren't they? So why don't we just call, I hate to use S. Let's call this X. Or even L. We'll go with L. Length. The length is 10 on all these dimensions. Okay, the diameter of the hole is 8. Well, if the diameter is 8, the radius is 2. Okay. So what is the surface area of this whole thing? So there's a couple ways to think about this. We have a cube that has a cylinder going through it, but the cylinder doesn't have the top and bottom circle. So we're adding the cylinder, but we don't have the top and bottom circle. So the surface area of a cube is just all 6 sides, the area of all 6 sides added together. So 6 times length times length. I can also say L squared. So that's the surface area of a cube. The surface area, so this is the cube. The surface area, let's say cube. The surface area of the cylinder let's do that, is 2 circles plus the unfolded sides of the cube that turns into a rectangle, right? And we just said before, that's 2 pi r, the circumference, times the height. We just saw that in the previous problem. Now, we are subtracting this out, these two circles, from our surface area, but we're adding this interior curve right here inside the culvert. So the surface area total here is going to be the 6 sides of our cube minus the 2 circles that are cut out, plus the curved interior part of the culvert that folds out to be a rectangle. So I encourage you to always approach these problems with the equation. Work out what each part is going to be and then put it together, instead of just starting to punch numbers in a calculator. Okay? You can follow my work here. If you start punching stuff in a calculator, can't follow anything. So, maybe let's make a list. L is 10 feet. R is 2 feet. H, the height that this cylinder has, so this height's going to be this right here, right? This is the height here. It's the same as the length. It's 10 feet. So now we can just put everything in. 6 10 squared minus 2 pi times, I made a mistake here. The diameter of the hole is 8 feet here. It says right here, and I put 2. So I was thinking that the radius was half of 4. So let's fix this here. The radius is 4. Maybe you saw that mistake earlier and you're thinking, oh, Mr. Mack's making a mistake. I was, but I caught it now because I've written everything out, and so I can see the mistake more easily. Or maybe I just got lucky, I don't know. So 4 squared here, okay, plus 2 pi times 4 times 10. Okay. So I'm just going to use the calculator here and put the whole thing in. And then it's good to do the whole equation in the calculator, in my opinion, because then we can check to see if there's an error and look on the calculator and see the whole solution laid out. 750.8, so 750.79, I'll say 8 square feet. This is the surface area of this culvert. Looks like a complicated problem at first, but I think if you break it down into the parts, put it together, substitute, it's not so bad. Okay, I'm going to stop the video here. Saw the last page from the practice set. I hope that makes sense.